cubic polynomials, we need to think about like when I take a linear factor out, I will be left with some quadratic polynomials, and I need to know how to factorize quadratic. Well, the thing is, I don't know how to factorize cubic, but I must know how to factorize quadratic. So this is the first thing we consider. If give you a quadratic ax squared plus bx plus c, if you can't see by eye whether I can factorize this or not, like it's not something quick. I can say, okay, this can be factorized or this can't be factorized. What we need to check is the discriminant. So something can guarantee you get the right answer is you check the discriminant. If the discriminant is less than 0, this quadratic cannot be factorized. So you don't need to bother with it. Okay, so give an example, 2x squared plus 3x plus 4. Let's say plus 1. I also factorize that. But I don't know whether it can be factorized or not. It seems yes, but maybe no. Like I want to check it first before I start doing things with it. So what I can do is discriminant equals to sorry, change that to 2. Discriminant equals to b squared minus 4 times 2 times 2, and that's a 9 minus 16. Is that a positive or negative number? Negative. So I can't factorize this one. So the conclusion is I can't factorize it. So for some quadratic, if you just want to see whether you can factorize or not, just check the discriminant and it will tell you whether it can be factorized or not. Okay, there's something, later I will ask you something. Can I factorize that? Yeah, do not answer me yes or no first. Check the discriminant first and then answer them. So for the first one, like for that one, that's the first thing I'll talk about for quadratic, how you can decide whether it can be factorized or not. Then the second thing we want to talk about is when we miss bx term. Okay, when we miss bx term, I don't have bx term. The formula I need to think about is a squared minus b squared in this case, because constant can always be put into square root of that constant square form, so I can always create a squared minus b squared form. So for example, this one, I can take common factor 2 out first. Okay, so this is the first step of factorize. I can take 2 out, or I can decide not to take it. Sorry, that's 8. And then I haven't finished because this is not a linear times linear. Factorize means linear factor. Linear factor. So this is not linear factor yet. So what I'll do is that's x squared minus root 8 squared. Hope you can see that. So 8 is a root 8 squared. Then that's a squared minus b squared. So it's x plus 2 root 2. Root 8 is 2 root 2. And then x minus 2 root 2. Okay, so a squared minus b squared is a plus b times a minus b. Okay, next one. Next one, obviously, I can see a 3 from 3 and 75. So I can take 3 as a common factor. That's x minus y squared minus 25y squared. Okay, common factor is always the first thing I want to check. Then 25y squared, that can be written as a 5y squared. Because if you don't write into this form, 25 is not in the square form. Only the y is in the square form. It's not satisfied with the formula says a squared minus b squared. So I'll put 25 into 5y squared form. Then what I'll have is a minus b and a plus b. So I'll go a plus b and a minus b. So that's x plus 4y and x minus 6y. I can factorize it that way. So we use these squares. We can put a square minus b square form. That's what you need to think about, how we can factorize that. When you have 3 terms, okay, we're not missing any term. When you have 3 terms, what we need to think about is cross multiplication. If there's something quicker, I can find it. So that's 1 minus 4 and 2. That can give you minus 4 plus 2 gives you minus 2. This works. So the factorize of that is read horizontally x minus 4 and x plus 2. Yeah, the first one is easy. I can factorize in that way. The second, Minus 15. Well, I don't like, to be honest, I don't like minus in the front, so I will take minus out as, well, it's not really necessary, but I don't really like negative in the front, so I want a positive a value, so I take the negative as a common factor. So 15, what's 15? What times what can give you 15? Yes, 5 and 3, so go 3, 5. And what can give you 12? 2 and 6, something else. 3 and 4, but I need a negative, so one of the number needs to be negative. Okay, so I want a 11. So if I put 4 here, make a 20. If I put 3 here to make a 9. 20 and 9 can give you 11, right? 20 and 9 can give you 11. And I need negative 11, so I need a negative 4 here to make a negative 20. Yeah, that's the thinking I have. So that's a minus 20 plus 9, and that gives you minus 11. Okay, that works. So minus 11, that's what I want. Minus 11, that's what I want. So read horizontally, that's 3x minus 4 and 5x plus 3. That's what we'll have. Okay. That's this one. And for the next one, x squared minus x plus 1. You know 1 can't make 8 for you. Like if I was to use cross multiply, 1 doesn't work. Like 1 can't create 8. So I want to test whether it can be factorized or not. What's the discriminant for this question? What's the discriminant? 64 minus 1. B squared minus 4ac. 1, 1, 4, so 4. Okay, so it's bigger than 0. So this can be factorized. That's the thing. The thing I also see is, okay, cross multiply doesn't work. But is that worth me to keep going? Should I try some other method to make it change the form to be able to factorize it? So now it shows me discriminant bigger than 0, which means I can factorize. So completing square is the last thing we want to try. Okay, completing square is the last thing we want to try. Why I didn't say start completing square immediately? Because if it's even not worth to try it, like you just wasted your time. So discriminant is easy to check compared to just directly start completing square. So now I check it, I can factorize it, then I can complete square for that. So it's minus 8x plus 4 squared minus 4 squared and then plus 1. So we have x minus 4 squared minus 16 plus 1 is minus 15. Okay, so minus 15 here, and that's the completing square one. And then I can write that, and then we use this step to make it a squared minus b squared form again. Because it's a minus in between, so it's a squared minus b squared. I can put 15 into root 15 squared. And what we have is x minus 4 plus root 15 and 8 minus x minus 4 minus root 15. I'll leave the last one for you to practice later. Just have a bit fun with that. I don't have enough time, so I'll skip the next one. Let's look at example 6. That's the key thing I want to talk about. Okay, trying to remember what we have learned last lesson. We have learned the synthetic method, the box, like the boxing, and then we learned the factor theorem and then remainder theorem. Just a general question. If px is divided by x plus 2, what can give me the remainder? How can I find remainder without doing long division? Substituting negative 2 into px, I will get the remainder. Okay, so we make x plus 2 equals to 0 and x equals to minus 2. We sub the minus 2 into px, we will find the remainder. Okay, if the remainder equals to 0, what that means is a factor x plus 2 is a factor of px. Okay, so that's the two things we have learned, and we have learned the box method. All right, let's start this question. The function fx equals to 2x cubed plus ax squared minus bx plus 3 has a factor of x minus 3. Okay, fx has a factor of -3. What you can say, like, how you can put that into math notation? What sub what equals fx equals to what? How to find remainder if I divide by x minus 3? You sub in 3, so f3. So the remainder is what in this case? 0. So f3 equals to 0. Okay, f3 equals to 0. So because it's a factor, there's no remainder. But how we find remainder? We sub 3 into the function to find remainder, and we find remainder equals to 0 in this case. Okay, next one. When fx is divided by x minus 2, the remainder is 15. What I can say? Yeah, f2 equals to 15. Great. All right, let's just expand that. f3. f3 is 2 times 3 cubed is what? 3 cubed is 27 plus 3 squared is 9a minus 3b plus 3 equals to 0. And then 9a minus 3b equals to minus 3 minus 54. And then 9a minus 3b equals minus 57. I'm just simplifying that. And divide by 3 on everything, minus 3a minus b equals to minus, divide that by 3, which is 19. Okay, that's the first equation. Okay, after simplify, the first one becomes this one. Okay, the first one becomes 3a minus b equals to negative 19. And f2 equals to 15. f2 equals to 15. So f2 is 2 to the power of 3 is 8. So it's 2 times 8 plus 4a minus 2b plus 3. But not equals to 0 in this case, that equals to 15 because the remainder is 15. So 4a minus 2b equals to 15 minus 3 minus 16. 4a minus 2b, that's minus 4. Then 2a minus b equals to minus 2. And that's the second equation. Okay, I put the second equation here. Just put it under each other. What I can do to find a subtract which one by which one? Top minus bottom. So doesn't matter, but a will be negative a if you go another way. So a equals what? Negative 17. Okay, a is negative 17 if you use 1 minus 2. Okay, if you use 1 minus 2, a is negative 17. And what's b? B, well, I'll use the second one to find b. b equals to 2a plus 2. And b is negative 34 plus 2. And b is negative 32. Okay, I have both a and b here. And now rewrite fx function for me. What's fx? Fx is 2x cubed. Then what squared? Minus 17x squared. And then plus 32x. And then plus 3. Yep. All right. Now I want to factorize that. I find the actual equation now. I want to factorize it. What information do I know already? So what is the factor already? X minus 3 is a factor. So no, you have to do long division. Use fx divided by x plus 3. You can do that. But another way we can do that is the synthetic. Yeah, that's good. So we have 2 minus 17, 32, and 3. What I should put here? What I should put here? Not minus, it's x minus 3 is a factor. So what I should put? 3. Okay, I should put 3 here. 3 is a solution. Okay, what's the first one? Let's do a little revision. What's the first one? 2. What's the next one? 2 times 3 is 6. 6 minus 17? Negative 11. And negative 33 plus 32? Negative 1. And negative 3 plus 3? 0. The last one must be a 0, which means there's a remainder. Okay, that's the remainder. So my fx can be written as x minus 3, that's one factor. And then 2x squared minus 11x minus 1. See that? Yeah? That's a quadratic. Okay? That's a quadratic. And my question is, can I factorize that quadratic? Yes or no? Like, well, not easily factorize it, but like, can I factorize it? Why yes? Yep, discriminant is bigger than 0. It's minus 11 squared minus 4 times 2 times minus 1. And it's all plusing, so it's definitely greater than 0. I can factorize it. Yeah, I can factorize it. I'll leave you to factorize that one. Like, it takes a while. I don't want to spend the time now to do that. I'll show you the answer later. But I really want to talk about how to factorize example 7. Okay, that's really important. Really important. Integer root. So first of all, there's no information given now. Like, I don't know what is the factor. I don't know any information. So I was trying to find something. Let's say, like, if fa equals to 0, then it gives you x minus a is the factor, right? So that's the thing. If you can find the a value, can give you the function equals to 0, x minus a must be a factor, like using the reverse way of the factor theorem. So now I want to find the a value. Can give me 0, like for this equation, like the solution of this equation. So what value worth us to try? Like, can I try a 5? Do you think I'll try a 5? This is important. Like, what value will try? So it's a trial and error process. Okay, so it's a trial and error process. Like, I'm not confident saying this must be a solution. This must be a factor. So I need to try. But the question is, what value wants us to try? Can I try a 5? Can I try a 7? Can I try a 10? Is that worth us to try? Okay. So if we can't answer that, what we need to look at is the constant. What's the factor of the constant? What's the factor of the 6? All the factors. 1, 2, 3, 6. Okay, the value worth us to do the trial and error is those values. Okay, it's the factor of the constant. We're not going to try something else. Okay, we're not going to try 7. We're not going to try 5 because it's not even worth me to try. Like, 5 won't work. Okay, I know 5 won't work. So integer root, you can only try the factor of the constant. So only plus minus 1, plus minus 2, plus minus 3, and plus minus 6 was us to try. And there could be multiple numbers work in those like number sets. But which one do you think we'll start with? Plus minus 1, right? We start from the easy one. So the method I recommend here is I'll draw multiple boxes here because it's a trial and error. I don't know what is like the actual value. So that's 1 minus 2 minus 5 and 6. All right, let's try something wrong first. I'll show you if you try something wrong what will happen. Let's try a 3. Actually, I don't know whether 3 works or not. Let's try a -2. Now, if it works, then we are really good luck. But I don't want a good luck. Okay, so let's try a -2. I'll see whether -2 can be a solution of this cubic. So what's the first number must be if I put the -2? What's the first number? First one. What's this number? This one. It's just copy from the top. So -2 is some number I try. Like it's like the thing I put beside. So I copy 1. So 1 times -2 plus -2. What's that? -4. Oh, this one works. Oh my god. Doesn't matter. Let's try. -2 times -4. What's that? 8 plus -5. 3. And 3 times -2 and plus 6. 0. Okay, why works? Because that's a 0, which means the remainder is 0. I don't have remainder. I don't have remainder, which means what is the factor? Okay, question, what is the factor? If -2 is the answer, is the solution, what's the factor? X plus 2, correct. X plus 2 is the factor. If you don't have 0 remainder, let's say we have a remainder 2, remainder 3, we just cross out that line and try another number. Just change something else, like we don't want it and change some value. Okay, what's the rest of the quadratic? So if it's x plus 2 here, what's the other things? What's the 1, -4, and 3? X squared minus 4x plus 3. Do you know why I said the synthetic method is good? Because you do the trial and error and you get the solution together in one step. Okay, you don't need to try and get long division, like you get everything in one step. Like that's it. Okay, we get everything in one step. So after we finish that one, I can just try that's a x minus 1 and x minus 3. I can factorize this quadratic easily. There's a x minus 1 and x minus 3. But the thing is, if you use synthetic method, I can get the solution and the try and error, whether right or wrong, like at the same stage, like at that one stage. So it's easier. Okay, it's easier. It's quicker. Otherwise, you start the value into that fact to get the value. Oh, that's a 0. Then I need to go back. Oh, I need to do long division. So it's another step. This one is just finishing one step. That's why I highly recommend this method to you. But there are some nightmare things. If you look at example 8, it's called the rational root theorem. Okay, the previous one is the integer. Okay, so I got an integer solution. That's good. Okay, that's cool. First of all, still, what value worth us to try if we try integers in this case? We see the value of 3. What's the coefficient? Not coefficient. Factors of 3. 1, 3. So plus minus 1 plus minus 3. And also you can see in this case we have coefficient 2 for the first term as well. Okay, for the first term as well. So what's the factors of 2? Plus minus 1 plus minus 2. So overall there are 3 values worth us to try, which is plus 1 plus minus 2 plus minus 3. And the nightmare is none of those works. Okay, if you stop that into the table, none works. The integer doesn't work. Okay, so all the integers doesn't work. So I need to think about, well, first of all, you need to try. Okay, try those 6 values and you figure out that it doesn't work. Okay, so I tell you now, like, it's save your time, doesn't work. Now we need to think about some fractions. So what's the fraction? Is the factor of the constant over the factor of leading term. Okay, so this is the fraction I can create. It's the factor of the constant over the factor of the leading term. So what other values you can create? Well, you can't flip it. Only the factor of the constant over the factor of the leading term. You have 1 on 2, and you have 3 on plus minus 3 over 2. And that's the only 4 values you can create. You can't, you won't have 1 on 1, 3 on 1. That's just 1 and 3. You will have it, but it's the same as the integer. So now you will try those 4 values. There must be one works. If still doesn't work, which means you get some calculation errors in your calculation, and you need to go back to check everything. So if you want to solve by hand, it either works in those integers or it works in these fractions. Okay, so there must be one works. If they gives you the question, you can definitely factorize it. They won't give you something you can't factorize. And basically all the cubic can be factorized, but some factorized can be factorized by hand, some can't. So the one that gives you must be able to factorize by hand. Okay, so let's try one. Like you pick one for me. Which one do you think looks good? Plus minus half, plus minus 3 on 2. Pick one. Half? Okay, let's try half. You have a quarter of the chance to get it right. Well, there's no luck. Okay, this is really by luck. So you can't just say, I definitely got this right. Like you just need to try it. So 2 minus 1 minus 1 minus 3. Okay, we decide to try half. Okay, what's the first one? 2. And the next one? 2 times the half is what? 1 plus negative 1? 0. Yeah, 0 times the half is 0. 0 plus negative 1 is negative 1. And that's definitely not going to be 0, right? Negative 1 times a half plus negative 3 can't be 0. So this one doesn't work. Yeah, this one doesn't work. You have some remainder here. Okay, pick something else. Don't tell me negative a half, I think. I'm not sure which one works, actually. Negative a half. Oh, I'm not sure, okay? Do not blame me if it doesn't work. I think it's not negative a half. Okay, that's 2. Negative 1, negative 2. And what's the next one? What's a half times 2? It's 1. 1 plus negative 1? 0. Negative half plus times negative 2, that's 1. Negative half plus negative 2, that's 1. 1 plus negative 1, that's 0. So do not look at this one. This one doesn't work anymore. Okay? And then 0 times that is 0. 0 plus that is that. Still doesn't work. So this one is no good. Okay, you have half of the chance. Pick another one. Negative 3 over 2. Okay, negative 3 over 2. So first one is 2. 2 times negative 3 on 2 is negative 3. Negative 3 plus negative 1 is negative 4. And the next one, I think this one doesn't work either. Because I know what alpha should look like. And the number doesn't, it's not the same from my memory. Let's try that. I think this one doesn't work. You can keep going. So that's a 2. 3 times plus minus 1, that's a 2. 3, that's a 2. And that's a 0. This one works. Finally. So what's the factor? This one works, but what's the factor? No, factor is involve x minus that. Correct. And we have 2x squared plus 2x plus 1. Plus 2, sorry. And I can take a 2 out to put into the other bracket to make it look better. No, no. No, you can't just leave it. You take the 2 from the second bracket and then make it contribute to the first bracket, which makes the equation look better. So it's 2x minus 3 for the first one, and then the second one, get that. And can you keep factorizing the quadratic? Reason? So what's the discriminant? Yeah. Okay. Because that's 1 minus 4 times 1 times 1. That's definitely less than 0. So I can't factorize. So I'll leave my answer like that. Okay. Last two. Yeah, it's time to test you about that. What's a cubed minus b cubed? If I ask you to factorize. B squared is here, and then the sign here. What's that? No. A plus b minus ab and plus b squared. It's just flip the sign. This is minus, then here's plus. Here's plus, then here's minus. That's it. If you expand it, will be the same. Try to expand it. Well, it's just a formula, and you just remember it. Okay? You don't need to know how they create it. It's basically about long division. It's basically about long division to get it. But don't worry, just leave it and remember it. I think it's easier to remember it. So let's try to make this one work. So x cubed minus 3 cubed. So what we can say here? So what's that? How we can factorize that? Yeah, so x minus 3 not equals to. It's okay. Yep. Yep. Plus? No. No. Okay. Just match the formula. A is x, B is 3, and then match the formula. And do you think you get better factorize the quadratic? I think you answered too quick. What's the discriminant? Greater than 0, smaller than 0. Less than 0. So can't factorize. Okay. Tell us something good. When you use this formula, the quadratic won't be able to factorize anytime. If you apply this formula, if you try to factorize by this way, this quadratic cannot be factorized. It cannot be factorized. If you use this formula, the a cubed minus b cubed and a cubed plus b cubed, the quadratic you have in the second bracket won't be able to factorize anytime, any situation. So that's it. That's how you factorize it. Okay, last one. Yeah, last one. Let's try that. So what that equals to? Yeah, 2 plus a over 3. 2 squares what? 4 minus? Yep, 2 over 3. Last one. That's it. And you know what? I'll do something you don't like. Tech free. Basically, it's all this exercise. So what I'm talking about today. So how to find effective? Hmm? Well, you have something a little bit like in the front. I thought I was factoring like BNC. I think mainly BNC. Wednesday, last second period. You have two periods. Oh, you can leave it. Like you can leave it. Like I just want to make it look better. It looks really, really nice. I need to just. But like you can leave in the second line. This is good. This is good. Okay. Okay, that's it for today. No, it just makes me feel happy. Yep.